Hey guys, so today's lesson is on equations. Yes, you've heard of it before, but this time we're upgrading it to the next level, alright? So in grade 8, you'll be doing some very basic equations. So what we're doing today is we're just taking you to that next step. We need to implement the basics, but it's going to look a little more complicated. Before we continue, alright, if you're struggling with those previous equations, click on this link. It'll take you back to the grade 8 stuff. Don't stress. Doesn't mean you know what's going on. It'll just solidify what you were doing in grade 8 so you can take it through with us to this lesson here for grade 9. Now, this is the first example we're going to go through. So now when you thought, oh, I don't need to go back to that grade 8 stuff, but now you see this example and you think, oh, this looks a little bit scary. Click on that link that was up on the page. So this over here is an equation. Why is it an equation? Well, there's an equal sign, and we got something on the left-hand side and something on the right-hand side, which is saying that this side over here is equal to this. If you might have watched that grade 8 video, you would have known how I spoke about that seesaw life, how we're trying to balance the left-hand side with the right-hand side. Now that we're in grade 9, it just becomes a little more complicated. The basic steps are still there though. What are we solving for this equation? Well, we can identify that our unknown is x. So we're solving for x here. We're trying to find what the value of x is. So what is the first thing I need to do here? Well, I need to simplify both sides. Is there something I can perform on the left-hand side? Is there something I can perform on the right-hand side to make this a bit easier? Well, of course there is. On this side, we can see we've got a bracket. Now, in term 1, we did simplification. All right, so we should know how to do this. So we've got a -4 outside a bracket. We always need to try and do what's inside the bracket first. Can we? We've got 2x minus 5. We cannot do that because they're not like terms. So we cannot do that, which forces us to now multiply my bracket by the -4. And that means I need to multiply the 2x and the -5 by a -4. So -4 times 2x is going to give me -8x. -4 times a -5, the negatives are going to make it a positive, and it's going to be 20. Equals, we'll just repeat this because there's nothing else we can do on this side because we cannot add -4x and 10. Right, now that's the basics again. What are we trying to solve for? We're trying to solve for x. Now we're not going to balance out each side by doing what we need to do to each side because we're in grade 9 now. And we should know that we can just bring terms across this equal sign as long as we are changing the sign in front of it. So what I suggest here is that we want to try and keep the x positive, right? We're going to try and keep the x positive. So I've got a -8x here. If I take it to this side, it's going to become positive 8x. And then together with the -4x, it will become a positive 4x. So let's try that. So now we're going to leave the 20 on the side. I'm going to go equals -4x plus 10. Now because this is coming across to the other side, it's going over the equal sign, it now becomes a positive 8x. And now you might understand what I was trying to say is that by bringing this over, the 8x and the -4x will give me a positive 4x. So it's keeping that x positive. Now, what is on this side that can come across? The 10. So I bring it across. It's a positive 10 going over the equal sign, which makes it a -10 on the left-hand side. Equals -4x plus 8x. Now, as you can notice, I can simplify this. 20 minus 10 is 10 equals -4x plus 8x is going to give me a positive 4x. Now, again, back to those basics. The 4 is being multiplied by the x, or should I say the x is being multiplied by 4. That means to get rid of this 4, I need to divide this by 4. But because of the seesaw like we spoke about in grade 8, what I do to the one side, I must do to the other side. I then simply cancel those 4's, and I've got x is equal to 10 over 4. I've just switched it around. Don't be too confused. It's exactly the same thing. And all of a sudden, I can simplify this, that x is equal to 4 goes into 10 twice. And how many have I got left over? 2. And 4 is my denominator. Every teacher likes you to put it in its most simple form. So let me just move this up. So now we can simplify that x equal to 2 and 2 over 4 to x is equal to 2.5. Just quickly going through these steps again. This should be pretty straightforward. The next step, however, when I'm taking this -8x across, to keep it a positive x. You should be comfortable by now in your stage of going through this in grade 9. However, if you aren't, you can always bring the x to the left-hand side, which is what your teachers sort of remind you to do, because we're trying to solve for x, and whatever we're trying to solve for, we want to bring to that left-hand side. And then you'd find yourself, that would come over, become positive, you'd have a negative 4x, the 20 would go over and become negative, and you have negative 10. So you'd have, if I had to quickly say it to you, if we had to just skip this step and just jump to what you might be comfortable with, I'll just show you to show that you are still on the same track and we will land up at the same answer. If I brought this across, I'd have negative 8x. This comes over, becomes a plus 4x is equal to 10. The 20 goes across, becomes negative 20. So now I've got negative 4x is equal to negative 10. Now to get rid of this, to keep x on its own, I must divide by a negative 4. So I divide this side by a negative 4. These cancel, alright? And now I've got a negative divided by a negative. What do we know about that? Well, that becomes positive, alright? That becomes a positive. So they can just cancel each other out. And now we're left with the same answer as we had before. X is equal to 10 over 4. And as you saw, we simplify that to become x is equal to 2.5. So same thing, just different. So the next equation we look at is building on what we sort of learned at the beginning of the year again, where we're multiplying out brackets. And we're going to go back to that where we have a bracket squared and the tricks that we need to use in order to do it quite quickly. Now, the reason why, when you look at this video over here, just to remind you, all right, to go back, okay, check out this video again, and to tell you how to get that middle term nice and quickly. And there's a reason why we did that. It wasn't to try and confuse you. It was because when we get to exams, there is no time to waste. So if we're spending too long on a certain question, we're not going to have time to get to the next one. That's not saying you can't use the more sort of basic route to getting to the answer, but it just helps you if we just practice these. So I'm going to go and use that quick method when doing a bracket that is being squared. Now, over here I've got brackets which needs to be multiplied out. I can't perform what's inside of it, so I need to multiply the first term by each of these, and the second term by each of these. So x times x gives me x squared, and I've got x times a negative 3, which gives me negative 3x. Negative 2 times x is negative 2x. Negative 2 times a negative 3 is a positive 6. Move to the next bracket. 2 multiplied by x gives me 2x. 2 multiplied by negative 2 is negative 4. Equals. See how we now all of a sudden got lots of terms here. Very important, okay, I'm going to show you in the next step, that we make sure we calculate for each of these terms. Then we've got x plus 4 in a bracket being squared. We said we could square the first, alright, square the last, and to find the middle term, I multiply these together, which gives me 4x, and then double it. Minus 3x plus 10. If this step over here did confuse you, please click on the link that I was just raising to my left-hand side to make sure that you can get back to the basics. Now I'm going to collect on my left-hand side. I've got an x squared. Any other x squared terms here? No, no other x squared terms. So don't be shy to just cross it out and then rewrite it below. Now I've got a negative 3x, a negative 2x, and a positive 2x. The negative 2x and the positive 2x will cancel each other out, and I'm left with just my negative 3x. So x squared minus 3x, a plus 6, and a negative 4. Sorry, I should have cancelled that out to make sure that I know what I'm left with, and that's going to give me a positive 2. 6 minus 4 is a positive 2. Equals, I've got x squared, no other x squared terms, I can just leave that, alright, cross it out. I've now got my 8x and a negative 3x, so 8x minus 3x, those are like terms, and that will give me a positive 5x. And again, cancel them out. Now I've got 16 plus 10. We should know that. The answer is going to give me plus 26. Now, we can collect. Now, because you know that if I bring something over, the sign changes. I've got a positive x squared over here, and I've got a positive x squared over here. If I'm going to bring them together to try and collect them, this will become a negative x squared. So therefore, I can actually just cancel these out. And now I've got a negative 3x here and a positive 5x here. So let's just mix it up on that first one. I'll go straight and do it like we did the second time around, which is keep the x's on the left-hand side. So I've got negative 3x, and we'll just solve for that negative. Bring my 5x over, becomes negative 5x, equals, leave what's on that side already, 26. The positive 2 goes over, becomes a minus 2. Next step, collect. Negative 3x and negative 5x is negative 8x is equal to 26 minus 2, which gives you 24. Now, I need to divide this side by negative 8 to get this x on its own, because this is negative 8 multiplied by x. So in order to get rid of that, I need to do the opposite. So we need to divide. And what we do to one side, we must do to the other side. These cancel out. So I'm left with x is equal to 24 divided by a negative 8. Well, first of all, what's a positive divided by a negative? It's going to give me a negative, and 24 divided by 8 is 3. So my answer is negative 3. If you're doing this for homework, and you want to make sure that this is the right answer, how do we go about that? Well, you take this negative 3, and whenever you see an x, I want you to put a negative 3 and solve. And you'll find that this side is equal to that side. That's why it's an equation. It's that seesaw life. We're balancing the left-hand side with my right-hand side. All right, so now we're going to step it up a bit. We're going to make it a little bit harder, because we're going to sort of now introduce some fractions to you. But before we get to fractions, I want us to feel comfortable. So I'm going to show you a little grade 8 example, revision of grade 8. So we can really walk through this together, step by step. So I've got x over 2 is minus 1 is equal to 4. So it's asking me, what divided by 2 minus 1 gives me 4? Well, I know that if I'm trying to solve for x, which is now x over 2, I need to try and isolate this term. Isolate meaning put it on its own. So what I'm going to do, well, there's a minus 1 on this side as well. So let's get rid of that minus 1 and throw it to the other side. And we know if something goes over the equal sign, I'm going to change the sign in front of it. So I've got x over 2, let's keep it in black, x over 2 equals, because this is now gone across, 4, always write down what's on the side already first, that goes over, becomes plus 1. So now I can collect there, so now I've got x over 2 is equal to 5. Now previously in the examples I said to you that if we had something multiplied by my x, I had to do the inverse, the opposite, so I had to divide. Now I've got x divided by 2, so I want to get rid of this 2. I want x on its own. So if x is being divided by 2, I need to now times both sides by 2. So I would say 2 times this and 5 times 2. Because of what I've done to one side, I must do to the other side. It's only fair. It's that seesaw life. We're balancing the one side with the other. So if I had to multiply this now, these would cancel out. I'll be left with x. If that was a bit too fancy for you, don't worry about it. I'm just trying to show you why, right? Why we are allowed to just times that side by 2. Because we're doing it to both sides effectively. So if you were confused by that, don't worry. You can just take this 2 to the other side and it becomes a times. Because on this side it's divide, take it across, it becomes the opposite, it becomes multiply. So now I've got x is equal to 5 times 2, which is 10. And we can check that because 10 divided by 2 is 5, minus 1 is 4. 4 is equal to 4. Correct. It balances. Makes sense, right? So let's take you to this example over here. Now I'm going to erase this because there's 2 ways that I would like to propose this sum over here to you. You know what? I'm actually only going to do it one way because that other way is very tricky. Actually, it's not. It's just a trick which will save you a lot of time. If you want to see it, come to our masterclasses. We'll be letting you know very soon times, dates, places, where you need to see me and Russell. We'll be giving you all those extra tricks to make sure you do really well in your exams. Now, I've got negative x over 3 is equal to 2 over 9. How am I going to solve this? I've never seen something like this before. But then I remember. This is a fraction. And so is this. I know how to deal with fractions. So why should I not be able to deal with these? And I know I can only compare apples with apples. So if I am to perform a task on this to make sure I can solve for x, let me first make sure that my denominators are the same. Is there a common denominator here? There is, it's 9. So this will stay the same. But what do I need to do over here? Well, I need to times this by 3. And what I do to the top, what I do to the bottom, I must do to the top. But now. When we deal with algebra, I don't want you just doing this little grade 7 times little 3 there. I want you to perform this task using brackets. So if you're going to multiply the top, because we're not always going to find that there's one term on the top. If we're going to multiply the top, I want you to put the top into a bracket, and whatever we're multiplying it by, put it in front. So I'm going to have a 3 bracket negative x over 9. Notice, I've put my term in a bracket. Whatever I need to multiply it by goes in front, because a number next to a bracket means multiply. So now, equals 2 over 9. Now here's the fancy thing. With equations, if my denominators are the same, I can drop them and solve with my numerators. So now I leave them alone, and my new sum is 3 bracket negative x is equal to 2. Get rid of the bracket, negative 3x is equal to 2. If I'm to get x on its own, let's use red to show you the task here. Divide by negative 3, divide that side by negative 3. What's going to happen? These are going to cancel out. I'm going to have x is equal to 2 over 3, and it's a positive divided by negative, so it's going to be a negative. So my answer is x is equal to negative 2 over 3. Alright, so here we go. We're saving the best for last. Now, I say we're saving the best for last because this is that real step up. We're now taking it to the next level. And if we just practice what I've told you before in this video, you should be fine to get to this step. Because it's basically just the first line that we need to get through, and then we'll get back to what we've done before. So just follow me, keep to those rules, and you'll be absolutely fine. So let's look at it together. What do we see? Well, we've got fractions, whole numbers, fractions, equation. So we know that if we are to make sure this works, first of all, make everything a fraction. How do we turn a whole number into a fraction? We put it over 1. Anything can be turned into a fraction, any whole number, if we just put it over 1. 4 can become a fraction by becoming 4 over 1. It does not change the value of 4. It remains 4. It's just 4 over 1 is now in a fraction form, and it's easier for us to compare with the other fractions because we can find a common denominator. Let's ignore this for now. So, what I'm going to do is, first things first, I'm going to put this 1 over 1, so it's now also a fraction. And we can now enter the game with the other fractions. Now, in order for us to compare fractions, we need to make sure we have a lowest common denominator. What is my lowest common denominator? I've got 3, 2, and 1 with another 3, same as this 3. Can all of them go into 3? No. So I need to find the next multiple of 3. 6. Can they all go into 6? Yes, they can. So that means I need to multiply. So my LCD is equal to 6. Don't forget that. So I need to say 3 times 2 gives me 6. 2 times 3 gives me 6. 1 times 6 gives me 6. And 3 times 2. Now, as I said to you in the previous examples, I cannot just go and say times 2. Because now you're going to realize, now you're actually going to see. Because I'm going to say times 2, you're only going to multiply the 1 by 2. But I need to multiply this whole numerator by 2. And that's why we use the brackets. So, now you're going to get a first-hand experience as to why we use brackets. Now, what's being multiplied? I need to put it into a bracket. So it's going to be x plus 1 in a bracket. What's it being multiplied by? 2. I'll still put the denominator for you. Over 6, that's my common denominator, is equal to. Now, what's my numerator being multiplied by? It needs to be multiplied by 3. So I've got in a bracket, x minus 1. What's it being times by? 3. We'll leave the common denominator of 6. I'm not going to make it one long one because some people get confused. Plus, what's the next one? 1. What's it being times by? So put 1 in a bracket, it's being times by 6. And the common denominator here is 6. And then I've got plus again. And I've got 2x. And what's it being multiplied by? 2. It needs to be times by 2. So I put it in a bracket and I multiply it by 2. And again, my common denominator is 6. Now, as I explained to you that once we have our common denominator, we're dealing with equations, we can just get rid of it. Because I'm dealing with equations, please don't get confused with this when you are adding or subtracting fractions. You cannot just get rid of the denominators because it's adding and subtracting. Now, let's get rid of these brackets. So 2 times x and 2 times 1. Why am I doing that? Because I can't add x plus 1. They're not like terms. So 2 times x gives me 2x. 2 times 1 is 2 is equal to 3 times x, 3x, minus 3 plus 6, because 6 times 1 is 6. And over here, plus 4x. Let's collect all my x's. So I've got a 2x on this side, which I'll write down. I've got a 3x on this side, so I bring it over to this side, and it becomes negative 3x. And I've got a lonely 4x on the bottom over here, it's a positive, so when we bring it across, it becomes a minus 4x. Equals, what are my constants? My numbers without variables that are already on that side? Negative 3 and a positive 6. Anything on this side that needs to go over? Yes. So I'm just going to highlight quickly all my constants. So my positive 2 goes over and it becomes negative 2. Now I can simplify. 2x minus 3x, negative x. Or negative 1x, same thing. Minus 4x, negative 5x is equal to negative 3 plus 6 is 3, minus 2 is 1. Now I need to get x on its own. These are the basic steps. See how we've gone from something complicated to this over here, which we are now comfortable with because we know how to multiply out of brackets. Then we get to the simplification, and now we have this step over here, which takes us back to that grade 8 equations. And we need to divide this by negative 5, so we can get x on its own. But what we do to the one side, we must do to the other side, so divide that by negative 5. These cancel out, so I'm left with x is equal to, what's a positive divided by a negative? A negative 1 over 5. And it cannot be simplified any further. Look at that. You've gone from this to get to the answer down here. Step by step. Don't skip steps. Take your time. You have the ability to do it. I believe in you.